What's up everyone, my name is Jaco and this is the first video of a brand new series covering data engineering concepts. I'm gonna also be covering every single week concepts about AI and machine learning, but yeah, we're gonna start from the very beginning and building up from there. So yeah, in this video we're covering SQL for data engineering, and I'm gonna walk you through all the core SQL concepts you need with real queries and real results side by side. No filler, just the stuff that actually matters. Now, super important, in the description below, there's a link to our community where you can practice everything. I show you here with hands-on exercises, and the video and the exercises work together. So definitely check it out after that. All right, if you like the video, please give it a like, subscribe, and without any further ado, let's jump right in. Okay, what's SQL? Basically, it's a language that databases understand. Postgres, Snowflake, BigQuery, they all use SQL. You learn it once and you can work with pretty much any database out there. And the cool thing is, you don't tell the database how to get the data. You just describe what you want and it figures out the rest. That's what makes it so nice to work with. For data engineers, SQL is the main tool. Your data is already sitting in a database, so you just query it and no need to move it somewhere else first. Okay, every SQL starts with these two words. Select is which columns you want, and from is which table. Think of a table like a spreadsheet. Columns are the fields, rows are the entries. So here we're saying, give me order ID, amount, and a status from the orders table. And on the right side, you can see exactly what comes back. 3 columns, 5 rows. That's literally the base of every query. Everything else we'll learn today just adds up on top of this, okay? Now, what if you don't want all the rows? That's where comes in. It filters, it checks every row and only keeps the one that matches your condition. So here, where amount greater than 100. Out of 5 rows, only 2 come back, the ones over 100. The rest just don't show up. One thing to remember, strings go in single quotes in SQL. And a cool detail, where actually runs before select. So you can filter on columns you are not even showing in the result, okay? Okay, so where is great, but you have more tools for filtering. And means both conditions have to be true, or means just one is enough, you know? Like, let's just search for patterns. That percentage sign is a wildcard. So this finds all Gmail emails, for example. In is super handy when you have a list of values to check against. Way cleaner than writing a bunch of ors. And between gives you a range. Now, null, this one confuses a lot of people. Null means unknown. It's not 0, it's not empty. And you can never write equals null. It just doesn't work. Always use is null or is not null, okay? Order by sorts your result. By descending means highest to lowest, ascending means lowest to highest. And without order by, the database returns rows in whatever order it feels like. So never assume. Limit just caps how many rows come back. Really useful when you're exploring your data and you don't want to load millions of rows by accident. So here, we get the top 3 orders by amount, biggest first. Okay, so you have 5 orders and you want to know how many are there. What's the total revenue? What's the average? That's what aggregate functions do. They take a bunch of rows and give you one summary. Count rows. Sum adds them up. Average gives the average. Min and max give you the smallest and largest. Look at the result. 5 rows went in, 1 row came out with all the answers. These 5 functions are like 90% of what you'll use, and use AS to get use AS to give them readable names. Okay. Okay, but what if you don't want one tool for everything? You want a total per category, like how many orders per status. That's group by. It splits your data into groups and runs the aggregate inside each one. So here, 5 orders go in, 3 rows come out. Okay, 1 for completed, 1 for pending, 1 for refunded, each with its own count on revenue. One rule to remember, every column in your select has to either be in group by or inside an aggregate. Otherwise, the database doesn't know which value to show for the group. Okay, Now, what if you only want groups that meet a certain condition, like only statuses with more than one order? You cannot use where for that, because where filters rows before the groups even exist. That's what having does. It works after grouping. So the database groups everything first, counts the orders, and then having says OK. Only keeps groups where the count is more than one. So refunding gets dropped because it only had one order. 3 groups down to 2. Alright, before we get into joins, let's talk about why data is split into different tables in the first place. Imagine you have 1,000 orders and every single one repeats the customer name, email, phone number. If that customer updates their email, you have to change it in 1,000 places. Miss one and your data is wrong. So the solution is store the customer once, give them an ID, and just put that ID in the orders. Clean, no duplication. But now your info is in 2 separate tables. When you need the full picture, you use a join to connect them. See how both tables have customer ID? That's the connection. Okay, inner join takes 2 tables and combines them by matching a shared column. Here, the on says, connect rows where customer ID matches on both sides. When there's a match, you get one combined row with data from both tables. So now the customer name shows up right next to their order. If there's no match on either side, that row just doesn't appear. Look at the result, orders and customers merge into one. That's what joins do. Left join is similar, but with one key difference. It keeps every row from the left table even if there's no match. Where there's no match, you just get nulls. That is really useful for analytics because you want all customers, even the one with 0 orders. See Pioneer here? She has no orders, but she still shows up in the result. That's also a right join and full outer join. But honestly, you almost never need them. Left join handles more cases. So yeah. Okay, here's a common situation. You want all orders that are above the average amount. Your first thought might be to put average directly in where, but that doesn't work. The database hasn't calculated the average yet at that point. So what you do is you write a separate query inside parentheses that calculates the average first. That inner query gives you 124, and then the outer query uses that number to filter. 2 orders come back, both above the average. That's a subquery, one query fitting into another. Okay? You can also use a subquery where the table names goes in the from clause. The inner query produces a result, and the outer query treats that result like a table. Here the inner query gets the average per status, and the outer query ranks them. It works, but notice how you have to read the code from the middle outward. It gets confusing pretty fast, especially when you start nesting multiple levels. That's exactly what the problem CTEs resolve. Let me show you. Okay, CTEs, or common table expressions, instead of nesting queries inside each other, you write name steps at the top using with, and then reference them by name. You read the code top to bottom instead of inside out. Think of it like writing a recipe. Step 1 does one thing, step does another. And at the end you combine them. Each step has a clear name and a clear purpose. They don't make your query faster or slower. It's purely about making your code easier to read. And trust me, that matters a lot when someone else has to understand your query. Here's a real example. First, CTE filters to only completed orders. Second, CTE takes those and aggregates per customer. How many orders, how much total. Then the final query joins with the customers tables to get the names and sorts by value. See how you can read it top to bottom? Filter, aggregate, present. Each step does one thing, and the names tell you exactly what's happening. This is how SQL looks in the real world. Clean, organized, readable. This is something really worth understanding. SQL doesn't actually read your query in the order you write it. It has its own execution order, and knowing it explains a lot of confusing behavior. It starts with from, loads the table and does the joins, then where filters rows, then group by, then aggregates run, then having filters the group. After all that, select runs, then order by, and finally limit. So when people ask, why can I use my column Alice in where? is because where runs before select even happens. Once you know this order, a lot of things just click. All right, let's put it all together. This query uses everything we've covered. The CTE at the top of grabs only 2024 orders. Then we join with customers to get the country. Where removes any unknowns. Group by gives us one row per country with the totals. Then having keeps only countries with 10 or more orders. Order by sorts by revenue. And limit gives us the top 10. Okay? Every concept from this video working together in one single query. This is the kind of SQL you write in production. And once you're comfortable with this structure, you can build pretty much anything. So that's the full SQL foundation. Select, from, where, order by, limit, aggregates with group by, and having, joins, queries, and CTEs. The pattern you'll keep using is CTEs to clean your data, joins to enrich it, aggregation to summarize, and having to filter out the noise. That covers the vast majority of SQL you write as a data engineering. All right, that's all for today. Remember, everything I show you here has hands-on exercises you can practice. The link is in the description, so go check the community. If you get value from this, leave a like, it really helps. And subscribe if you want to follow along with the rest of the series. We're just getting started. I'll see you in the next one. Happy learning. Bye-bye.